Hello students. In the last class we are discussing about different types of energy change. Observe different types of thermodynamical physical quantities, and through that we have discussed that internal energy, enthalpy, work done, heat change, like this. And what are the relations between them? Today we will discuss one important law of thermodynamics, that is first law of thermodynamics. First law of thermodynamics. First law of thermodynamics. The law states that whether it is a physical change or chemical change, the total energy remains constant. That means there is no loss or gain of energy. One energy is converted to another. One energy can be transferred to another. Energy always remains constant, only we can convert one form to another. Energy is always conserved. It has no loss or gain. So that is called first law of thermodynamics. Energy neither be created nor be destroyed in any physical or chemical change. You can write down this thing. Energy can neither be created nor be destroyed in any physical or chemical change. That means total energy before change is equal to energy after change. Total energy remains same. No loss or gain of energy. Energy always constant, only it can transfer one form to another. You can convert heat energy to electrical energy, electrical energy to heat energy. You can convert that mechanical energy to electrical energy. So many ways. So different types of form of energy, only it can be interconvertible. But there is no loss or gain of energy according to first law of thermodynamics. So let a system, let it be like this. Suppose this is a system. It is a system having internal energy E1. This is the internal energy of the system. Then you supply Q amount of heat. Q amount of heat you supply to the system. Now, energy of the system after getting this, it will be E1 plus Q. Because E1 was the energy, initial energy of the system, and Q amount of heat is given to the system. Then system will absorb Q amount of heat. So it will be E1 plus Q. Now, let what happens, work done on the system. Work is done on the system. Let some work is done on the system. We know work done on the system means plus W. Work on the system is positive. In the last class already discussed. Work done by the system is negative. So now what happens? This will be total change will be E1 plus Q plus W. W is the work on the system. So work on the system means it is E1 plus Q plus W will be the total energy. Let it be the U2. What is U2? U2 is the internal energy of the system after change. E1 was the earlier, then Q amount of heat is given, the energy is U1 plus Q, then work is done on the system, then work is done in system means W will be added. Now total energy is U1 plus Q plus W, that will be the final internal energy of the system, that is U2. Now what happens, you can write that E1 plus Q plus W is equal to U2. This is the final values. Now if you arrange this one, what happens? U2 minus U1 is equal to Q plus W. Then U2 minus 1 is delta U. Change in internal energy is equal to Q plus W. Here indicates Q amount of heat is absorbed, W is the amount of work done on the system, and that will be change in internal energy, delta U Q plus W. This is the derivation of first law of thermodynamics. Delta U is equal to Q plus W. But already you know, if Q, delta U is equal to Q plus W, that we can write in another form. Already you know, if enthalpy change, this is the first formula of the thermodynamics, first law of thermodynamics, but already you know that in the second case you can take, you know, enthalpy change at constant pressure is equal to enthalpy change, that means energy change, heat energy change at constant volume, plus P del V. What is P del V? P del V is the amount of work done. Here enthalpy change at constant pressure is equal to enthalpy. It is your heat change at constant pressure, that is enthalpy change. A heat change at constant volume, that is internal change. Constant volume means internal energy change. Constant pressure means enthalpy change. And PW, this is the amount of work done. So this formula also a part of the first law of thermodynamics, that is delta H U is equal to delta U. Already I have told you enthalpy change always greater than that internal energy change. Amount of heat change takes place at constant pressure is always greater than heat change takes place at constant volume. The amount of heat absorbed or involved by the system at constant pressure is always more than the enthalpy change or energy change at constant volume. How much? P del V. That is, the difference is amount of work done. That means enthalpy change minus internal energy change is equal to work done. The result will be work done. But in the gaseous system, this formula can be written as if delta H is equal to delta U plus del nRT. What is this? This is the formula because we know PV is equal to nRT for gas loss. So P del V is equal to del N GRT. What is del N? Del N is the change in number of gas molecule, that is product minus reactant. This difference is product minus reactant. So this is the, you can write G here. So this is the derivation of first law of thermodynamics. Okay, let us discuss some numericals regarding to first law of thermodynamics. But before that, I will discuss some conditions. Condition is like this: if work done is 0, if total work done is 0, then what happens? Your enthalpy change will be equal to internal energy change. Both will be same. In the second formula, then another formula, this case, if delta work done is 0, that means total internal energy change is equal to amount of heat absorbed. if work done will be 0, if work done on the system is 0, then amount of internal energy change will be equal to W, equal to Q, because W is 0. This is the condition. Second condition we can use isothermal condition. If isothermal condition, isothermal means temperature. If temperature is constant, there is no change in internal energy. Very important, remember this thing. If temperature remain constant, so total internal energy of the system will be 0. There will be no change in internal energy. If delta U 0, then what happens? After the formula, delta H, total enthalpy change, is equal to W. That means that amount of heat change takes place at constant pressure will be equal to what? Amount of work done. Delta H is equal to W. In another equation, that previous equation, that what happens? If you apply that delta U0 means that delta U0 means here delta U is equal to Q plus W. If it is 0, 0 minus Q plus W implies what happens? Your Q is equal to minus W. What does it mean? That amount of heat will be given, it will be what? It will be utilized in work done. So, if internal energy is 0, Q is equal to minus W. Value will be Q is equal to minus W. So, this is the important formula related to it. But another condition, third condition is like this. Adiabatic condition. Adiabatic condition means here there is no change in heat. So enthalpy change, that is there is no increase or decrease of heat between the system and surrounding. Heat will not transfer from surrounding to system or system. There will be no change in heat. Q0. If Q0, then what happens? Here you see, if Q0, so total internal energy change is equal to W. You said if enthalpy change is 0, enthalpy change, there is no heat change takes place, that means your which one? Internal energy change will be work done. That amount of internal energy is already present in the system, it implies to do some work. Suppose for example, this is the case fasting. We are even in fasting. During fasting what happens? We are not putting some food. We are not taking the food. Then what happens? Where we are getting energy? The internal energy stored in our body is utilized doing some work. That means your delta is equal to W. That internal energy will be, that internal energy decrease from the system because there will be no addition of heat. So internal energy decrease will be related to work done. That during fasting, our internal energy in the body stored is utilized to do some work. So this is the relation between what? That another condition, also very important condition, that if vacuum, fourth one also you can take, in vacuum if expansion or contraction takes place, in vacuum means here W is equal to 0, there will be no work done. If there will be no work done, same delta H is equal to delta U, everything is same. Or you can say that delta U is equal to Q, both are same. This is the enthalpy change relation, this is the, that both are same. This formula, both formula is same, only the symbol are different. So Q is also heat change. Heat change may be two types. Heat change takes place at constant pressure, heat change takes place at constant volume. So like this. Okay, so these are the conditions related to first law of thermodynamics. Let us discuss some numericals. The problem is like this. let it be the enthalpy of combustion, enthalpy of combustion of benzene C6H6 at constant volume is enthalpy of combustion of benzene at constant volume is equal to 3,263.9 kilojoule. This is the given. What is given? Enthalpy of combustion of benzene at constant volume is this much. At 25 degrees Celsius. Given. Question is calculate the enthalpy change at constant pressure. Question mark. Okay. Here one thing you just see, language in thermodynamics, you have to take care. One thing is language of the problem. You carefully read this one. What is given? Enthalpy of combustion of benzene at constant volume. Enthalpy change means heat change. At constant volume means indirectly what is given? Constant volume means enthalpy, that is delta U, because U is related to constant volume. Delta U is how much? 3263.9 kilojoule given. And here calculate the enthalpy change constant pressure. Enthalpy change means heat change. At constant pressure means delta H is asked. Here T is how much? T is 25 degrees Celsius. So you have to apply this formula. Here delta is delta U relation. We know that delta H is equal to delta U plus del N G RT. Already you know the formula here. Delta H is equal to delta U plus del N RT. Because here no data given. Because T is given means T is already equation. R generally not given. R already know. So enthalpy change, if you put this, it is asked for enthalpy change is equal to delta U as per the question 3263.9 kilojoule plus what is the value of delta N? Delta N can be known from the equation. We know equation as it is a that combustion of benzene. So delta H is, we will calculate plus del N G R into T. Here C6H6 plus O2 changes to CO2 plus water. If you balance it, here we multiply 6, here multiply 3, then total will be how much oxygen? That oxygen will be 15. Now 15 by 2 multiply. This is this is your benzene is liquid, this is your gas, this is your gas, this is your liquid. Physical state is very important for the expression of enthalpy change of any reaction, maybe physical change, maybe chemical change. So here del N will be the product minus reactant. Always it will be product minus reactant. Product is how many? Only gaseous molecule. Here 6 minus reactant is 15 by 2. So answer is how much? Minus 3 by 2. This is your delta N value. So you put this value. Now enthalpy change will be how much? 3263.9 plus del N value is minus 3 by 2 into R value is 8.314 in joule. As question given in kilojoule, you have to convert that 8.314 by 1000, that means kilojoule. Kj, it becomes Kj into T. T is how much? 25. 25 means 290. So this is the result. So if you solve it, try to solve it. I am giving 1 minute more. You try to solve the answer. What is the answer? Enthalpy change. You calculate it. Answer will be minus 3267. It will be minus 3267.9 kilojoule. 3267.9 to 0.6 kilojoule. So this is the enthalpy change at constant pressure, but enthalpy change at constant volume given. When T given, indirectly use the equation del S is equal to del U plus del N RT. So this is the derivation 1 problem. Okay, you complete it, you start next one. Next problem is like this. Okay. Now second problem is like this. What will be the internal energy change? What will the internal energy change for this reaction? What? If the system absorbs, how much? 15 kilojoule heat. Absorbs 15 kilojoule heat and does work. How much? 5 kilojoule. Okay, this is the question. What is the question? How much internal energy change will take place if the system absorbs 50 kilojoule of heat and does work 5 kilojoule? You will see the language, very important language. So symbolically delta U is asked. Absorb means, here absorb means Q. Q is equal to plus 15 kilojoule. Already know absorb means that is heat is positive. And does work means system is doing work. System is doing work means W is equal to how much? When system does work done by the system is negative. So this is minus kilojoule. Very important is sign of convention. First you have to read the question carefully and you derive the formula and the data whether it is positive or negative. In thermodynamics, sign of convention is very important. So you have to take care of this one. Okay? So Q is equal to 15 kilojoule and W is equal to 5. Why W is minus? Because does the work means system is doing work, minus, it is minus sign. And absorb means plus. So you apply the formula delta U is equal to Q plus W. Here that Q is equal to 15 kilojoule minus W means minus 5 kilojoule. Your answer is 10 kilojoule. This much of heat, this much of internal change, internal energy is increased. It is increased because positive sign. So this much of amount of internal energy is increased by the system. Okay. Second question is like this. What is the second question? Second question is if 5 kilojoule heat, 5 kilojoule work, 5 kilojoule of work, 5 kilojoule of work, okay, done on the system. Language is like this. 5 kilojoule of work done on the system when 15 kilojoule of heat given out from the system. You see the language. 5 kilojoule of work done on the system means W is equal to plus kilojoule. Clear? Done on the system means plus. And 15 kilojoule of heat is given out means emission, loss. Loss means Q is equal to minus 15 kilojoule. Then what will the internal? The question is calculate del U. Del U calculate. So formula del U is equal to Q plus W. Here Q is minus 15 kilojoule. and work done is plus 5 kilojoule. Answer is minus 10 kilojoule. You see the difference, first question and second question. First question here internal energy is decreased. In the second question, in the first question internal energy is increased. It depends upon the heat transfer and amount of work done. If work done on the system, work done by the system, work done on the system is positive, work done by the system negative, you have to remember. And heat absorbed means positive, heat avoided means how much? Negative. So this is a very important convention, and you can do many problems. You have to practice more. Okay, use different formula. Any problem, any doubt you have, you can interact with me. Okay, thank you all.